Hello again. We're talking this week about the six-pack, the rectus abdominis. Well, actually more to do with about the tendinous inscriptions of the rectus abdominis. So like a lot of things in anatomy, this title, the tendinous inscriptions of the rectus abdominis, sounds sort of quite lofty and mighty and complicated. But what it actually means, or what they refer to, is the lines that cross over the rectus abdominis muscle to create those sections that we refer to as the six-pack or the eight-pack, the catering pack. The tendinous inscriptions, or tendinous septa as they're sometimes referred to, are essentially connective tissue structures that divide up the rectus muscle and create these sort of isolated pockets, and it sort of seals them off a little bit like a heat sealer or a sandwich bag. Now, I can't say for sure, but I'd be 99% confident that they're the same cell structure and histology, if you like, as all the other connective tissue sheaths in this area or any others, and I can't see why they wouldn't be. You know, they do the job. The main job of those spaces is to create a protective casing, which is what all that connective tissue is doing that's wrapping around it, for the rectus muscle, or rather that group of muscles. And it also helps to prevent excessive bulging of the muscle, pushing out. Now, the rest of that dense fascial layers of the rectus sheath also provide quite a lot of stability to the whole of the abdominal wall. So why do we need the pockets for the protection? Well, if you think about it, this area is quite generally poorly protected when it comes to bone around it. Now, everywhere else in the body, we've got these bony cages that, provide quite a lot of protection. Rib cage wraps around the heart and lungs, and we've got this sort of strong bony skull up here to protect our brain. But our poor old viscera down here, our guts, are pretty close to the surface, and they only have a relatively thin covering over them. And of course, that is going to make this area pretty vulnerable. Now, when we were walking around sort of more hunched over on our knuckles, this wouldn't have mattered so much. The guts would have been a lot more protected as we spent a lot of time in flexion, and this would have protected the area from attack by predators. We could cover ourselves up. As we climbed up the food chain, we became upright. We started looking around. We needed protection for our guts as well as stability in this pretty unstable upright position, and that's what this grouping here is going to help to provide. You can think of it in terms of like they have in bulkheads in submarines, that if one area of the ship gets damaged, then the bulkheads can be sealed off and flooded, and then the whole ship doesn't sink, hopefully. We've got a similar kind of system in the chest, in the thorax, the lungs. So each lung is completely sealed off from the other, and the heart is sealed off from that as well. So one area could be breached. We could have a collapsed lung and pneumothorax, and the other would still operate. If you had a whole open section, then once one lung goes down, the pressure's gone, and that's it, we're stuffed. If the area on the rectus was covered by one continuous line of muscle, then any damage to it would render everything above it and below it pretty useless. It would also be unable to create the tension, and we sort of immediately wouldn't be able to get into any flexion to protect ourselves. Also, these muscles then, separated out like this, have the capacity to respond more effectively to load and pull from other directions, and this is really, really important for us. What we really need in this area is mobility and flexibility. We need to be able to rotate and move through our trunk, with bending and twisting motions. And we couldn't do that if this area was sort of encased in bone. And the other thing, whether we like it or not, is that we need to be adaptable as humans, and so we need to be able to expand our bellies to be able to take that fat on when it's available, which it always is, of course. And of course, you couldn't be able to expand rapidly with a bony cage around it. It's also worth noting that these tendinous bits, and like all the connective tissues, they're on four sides. So we've got above, below it, around the sides as well. It's all completely sealed. And we don't always see that when you look at the anatomy books. It's not always clear that you sort of see the bags like that. The outside edge of these individual pockets are kind of sealed or stitched to the rest of the abdominal wall. So on this lateral side of the rectus abdominis, all down here, we have what's referred to as a Raphae, which is a Greek word meaning stitch. It just exactly looks like that. It looks layers of tissue stitched together. So this stitch seals off the whole of the structure, but also the individual pockets, and it seals them to the underlying layers of the external oblique and internal oblique muscles, or rather fascia of those muscles, and then these are connected to each other as well and sit over the top of the transverse abdominis fascia, which of course encloses the transverse abdominis muscle. And this is a thing you always have to remember about any muscle, is that it has to be encased in a bag of connective tissue to hold it in place, create a separate organ and give it its integrity. Now the bag doesn't always have to be really strong like the ones we're looking at here or around the calf or the thigh, and so the density of the fascia over muscle depends a lot on the mobility the muscle needs to have, where it's located, and a few other factors. The other thing about abdominal muscles generally is that we need to think of them in the light of not just being on the front of the body. The only abdominal muscle that's only on the front, the anterior portion, is this rectus abdominis that we're talking about, and we'll talk about the others in another video, but they wrap all the way around the back. So as I said, rectus abdominis in humans helps to protect us in terms of armor for the guts, but also helping to pull us forward in a protective response. But of course it can also work against us if we're always being pulled forward into a posture that creates that and accentuates that flexion, and this is a very common thing in modern day life. And there's a lot of studies that have shown this position to be pretty problematic when it comes to lots of things like breathing capacity, shoulder and neck pain, and things like dementia and depression are involved in that, and even Parkinson's as well. So again, another subject for another time. The good news is that everybody's got a six-pack. It's just that it's not always visible, and we might need to lose a little bit of our fatty layer before we can see it. Now, you can always opt for the surgery and just sort of have them stuck there, in which case you can sort of pile a bit of fat behind, and that doesn't look weird at all. But some of them naturally are pretty weird looking as well, even when they're visible. Also, the consolation here is that although the muscle itself is doing an important job, just because you can see it, it doesn't make that thing, that washboard abs, any more functional than the one that you can't see. But if you are going to do it, then you've got to target that fat with those muscles that get rid of that fat, right? Yeah. Sadly not. You can't burn fat by doing specific exercises, or you can't burn fat in an area, it's not possible to burn belly fat, but that's another story. Anyway, those are the tenderness inscriptions of the abdomen. That's our six-pack. So how's your winter six-pack going? So please let me know, leave any comments below in the chat box, and please like and subscribe and do all those things you're supposed to do on social media, and I will see you next time.